on inventory modeling by YASH Technologies. Today we'll be discussing regarding a product that is used for inventory management. Currently, manufacturing and retail industries are facing a huge problem of inventory pileup experienced across products and raw materials. A large amount of space is also required to store the inventory, and storage space like warehouses and storage rooms cost money to build, rent, and maintain. Over inventory or under inventory, both cause financial impact and affect the health of business as well as affect new business opportunities. Effective inventory management provides a big opportunity for companies in order to attain significant reduction in operational costs. Industries that depend on conventional methods can save up to 30% on operational costs by maintaining optimal inventory. Effective inventory management provides a big opportunity for most companies in order to attain significant reduction in operational costs. Industries that depend on conventional methods can save up to 30% on operational costs by maintaining optimal inventory. Today, the industry in large is depending on tools and methods for inventory management that are strongly based on approaches which are not scientific and also deviate significantly from the ideal and optimal solutions and decisions. We present YASH data science-driven approach and methodology to inventory modeling through advanced time series regression models and optimization techniques to identify causal factors influencing the inventory. The platform provides predictive intelligence on the production requirements for avoiding inventory stock piling up and the decision making related to it. Now we'll be walking you through the solution. The data which is considered away as an introduction to the whole the product that we're starting with. As we explained, inventory modeling is basically the management of inventory stocks. The stocks that pile across over a period of time that affects the business negatively, and it affects the further business process, and inventory stock piling up will lead to wastage of resources, which further affects it financially and also the planning of the company. So inventory modeling is about managing the inventory in a most optimal and the best way we can so that the resources will be managed and it will be saved over a period of time that can be used for business resources requirements later. So just giving a business overview, high inventory is certain indicator of more serious and costly business processing systems problems that have been rooted very deeply across the organizations. Primarily, excess inventory locks up capital and reduces profit margins. By streamlining the entire supply chain, a company can reduce its inventory, improve time to market, compress cycle times, free up more cash, decrease costs, and improve profitability. Keeping all these things in mind, we have developed the current solutions on the basis of the limitations which are existing in the current market, and we have developed an approach to address these problems that are being faced by the industry today. So to narrow down the problem statements, the primary problem statement is to identify those factors which causes inventory pileup. Second is to propose an inventory reduction strategy to liquidate existing inventory from the ongoing process of the business. The third is to identify desirable stock levels for inventory, how to apply and set maximum and minimum value based on constraints. So just taking you through our approach, we have a multi-layer approach that we are looking over here. We start with a very extreme univariate analysis, which we identify the study variable and the variables that affect that, and we individually study those variables, primarily the study variable over here, which is stock piling up or the inventory that we have. We study this variable throughout to find out the patterns in the data, to identify the relation of this data with respect to other variables that we are studying, or the causal factors that we discuss about. We identify what is the time series nature of it, what is the seasonality related to it, do they fluctuate over a month, do they fluctuate over a quarter, do they fluctuate over a year, half yearly. Such patterns being identified from the data, and this is further used for analyzing how the inventory pileup would happen in the future. So the analysis starts with an extreme univariate analysis, which includes the descriptive and exploratory data analysis such as histogram, density plots, box plots, and then we move to a statistical time series analysis based on autoregressive and neural network as well as boosted algorithms that we use for the analysis. Once time series analysis or the univariate analysis is carried out, we move to bivariate analysis. Bivariate analysis is very helpful in identifying a single independent factor, that is a factor which is influencing our dependent variable here, which is inventory piling up. To identify what causes or what are the factors that cause inventory pileup or inventory stock up, we take these independent variables and we individually study their relation with the dependent variables stockpiling up. And this analysis is carried out in the bivariate analysis section. So over here, we use multiple methods to identify the relation. The first method is basically identifying what is the correlation between the correlation and causal factors and causal methods to identify the relation between the dependent, which is stockpiling up, and independent individual variables. So it starts with scatter plots, and then we move to regression analysis to identify what is the relation. And then it is concluded with the correlation and other coefficients for identifying the association between the variables. Once bivariate analysis is carried out, we identify the important variables which are used for the analysis for further process. Then we move to sensitivity analysis. A sensitivity analysis is essentially a scenario analysis where the moment of one individual variable, that is independent variable that we talk about, which causes the dependent variable to move and being affected by it, which affects its variance, to identify what is the relation of that particular variable with respect to the stock piling up is what being analyzed here. So what it would conclude is basically when we keeping everything else constant in a ceteris paribus condition, what happens if we move a particular independent variable and how it would move the dependent variable, which is stock piling up over here. Once sensitivity analysis is carried out, we move to aging analysis, which is to identify what contributed from the historical periods or the days that we talk about, which led to piling up currently that we face in the industry. So did that happen over a period of time? Did that happen over a year? Did that happen over months? So this is what being analyzed through aging analysis. Once aging analysis is carried out, we move to multivariate analysis, which is an exhaustive method to identify all the methods that we have analyzed so far, to combine them together to identify what factor contributes how much to the total stock piling up. And multivariate analysis is used for identifying the causal relation between independent variables, and their weightage is being allocated on the basis of multivariate analysis. Finally, coming to the business benefits, as we have already discussed, the business benefit is basically contributing the method, the platform would help the industry and the business to properly manage the inventory over a period of time. This will lead to the control of the excessive inventory that piles up over a period of time, and which will lead to essential, effective financial planning and management. Now going to the platform, we start with the data. Coming to the data, we have a platform which connects directly to the SAP. Now we will be getting data from SAP for analysis on the R platform. So as you can see here, we have data which has been collected across an industry, a particular use case that for particular implementation that we have carried out. And we have taken a very generic situation over here where the stockpiling up would happen across industries that could be observed. So as you can see here, we have the data which, with the first column, a particular date, and the stock that piles up over that particular day, which in terms of tons. And then we have consumption, which is how much of that particular raw material which has been there is being used for final production, and final output has been generated from that. So 49.5051 has been the initial stock tons that have been used, which has been there, and out of that, it has been utilized for 2.59 tons to make the final good that has been produced. However, there's a production loss, as you can see, in kilograms, which is 6.994. And for that particular day, however, the sales was 0, and the machine downtime, which is the time, the total percentage of the time where the machine wasn't running, that is 14.8%. So this is the initial data that we have taken, the raw data, which has been used for further analysis. And this has been taken for a particular period of time to identify and understand the time series nature of it. To get a simple summary of the output of the variables over here, as you can notice here, we have statistic, which you talk about the parameters or the variables that we talk about. And they're different summary output, the number of observations, that is a mean, standard deviation, mean, max. This is all for the statistical analysis purpose that we have done here. Now we move to data understanding. This gives an idea about what exactly the variable that we are studying over here and what are the factors that is being considered that would influence the stockpiling up. You could observe that in our method, in our analysis, we do consider the exogenous variables or the external variables that we talk about, how it would impact our dependent variable over here. Such variables are usually extracted from other sources, open sources, web sources, sensor data, other data that we have, which has been collected outside the system. to analyze how it would impact our dependent variable. The dependent variable over here is daily stock piling up that we have, and the internal factors that we have considered independent variables that we have are consumption, production loss, sales, and machine downtime. Also, we have considered external factor, which is basically price. Now, price has been an average price for the industry that we have considered from the web source. Now we move to data pre-processing or the data processing. Pre-processing includes methods such as we clean the data using imputation. That is, if there are any missing values, any is present in the data, an imputation method is carried out based on several different scientific methods such as the k-nearest neighbor and other imputation methods using random forest and other imputation methods have been used here. So it will be carried out on a cluster basis. For example, we cluster the data, each of it, and then the imputation is being carried out. So over here we have mean imputation, random forest imputation, and PMM. Different methods have been used over here. Once we carry out these imputation methods, we move to other methods for outlier treatment and other pre-processing requirements that we need in data to remove the noise and other bias in the data. Now, once the data pre-processing is carried out, we move to a univariate analysis. That's where the analysis starts with. However, before going to the pre-processing, we have to do transformation for causal analysis purpose. What essentially we mean by transform is basically standardizing all the variables according to a particular range. So that has been considered over here for further analysis. So transform, then data pre-processing. Once it's carried out, we move to the first initial part of the analysis, which is basically univariate analysis. In the univariate analysis, what we essentially do is basically identifying all the very descriptive statistics related to the data, which includes mean value, max value, of course, the range of the data, the mean, median, standard deviation, and we also do what is the distribution of the data in terms of probability distribution function. Or however, we're using a histogram over here to understand what is the density distribution of the data over here. So this is with respect to the stock piling up, and we have observed that there's a mean around 200 where the stock piling up happens the most. After this, we do analyze what is the distribution of the data over here, which is an interactive graph to understand. Even this can be carried out for a particular period that we consider, and it could be further drilled down to a particular range that we need. Once this is done, we move to the first part of the analysis in the univariate analysis, which is basically time series analysis. Now, time series analysis, there are multiple approaches that we have considered over here. For the time series analysis, we initially start with a strong decomposition of data. So we study the data thoroughly to understand what are the seasonalities that are existing in the data that we have. As you can see here, this is the initial data. We observe this particular trend in this data that we have considered, which is consistent across the time. However, from data to data, there could be structural breaks in the data, and there could be more irrational or fluctuating the patterns in the data that might observe across time series. However, in this data that we have considered, we have identified strong trends and seasonalities across. Once we have decomposed the data, we get three outputs that includes trend, seasonality, and random. When we analyzed across different seasonalities that we had, we did monthly seasonality, quarterly seasonality, half-yearly seasonality, and yearly seasonality. We identified the weekly seasonality to be very strong over here. So we have considered the weekly seasonality over here, which is across a week, how the stock piling up behaves with a particular range. So this seasonality has been extracted, which is consistent across time. And then we have removed what are the random variables in it. So we have identified what are the random component in it, and that has been extracted. However, for the further analysis, we move to by smoothing the data and other differencing methods. So it starts with ARIMA, which is autoregressive integrated moving average model. And ARIMA includes an autoregressive content and difference content, which is I. And then we have MA, which is moving average component. In this case, what we do is we have carried a very simple analysis without much adding of the seasonality. However, as you can see here, when we add the seasonality, the nature of the output changes with time. We have given a simple output over here to show how the data behaves when there is no seasonality added to it. Once the seasonality is added, the line moves according to this thing. However, this is the generic trend which is observed across time. Now we move to a couple of other methods like XGBoost and neural network. Over here, the prediction is carried out directly without the decomposition of the data. So as you can see here, we have decomposed the data. Without decomposition of the data, the forecast has been predicted using a boosted algorithm. So XGBoost is basically a boosted algorithm to identify how the predictions would occur over a time series data. So we have used multiple methods, and we have shown only 3 methods over here to identify how basically it works in the analysis. So once we have the prediction with respect to univariate data that we have, that is with respect to only stockpiling up, we move to bivariate analysis. In the bivariate analysis, we start with the data. The data includes the date, stock, consumption, sale, and then once we raw data that is already discussed, we move to the first part of it, which is basically exploratory data analysis. In the exploratory data analysis, we identify what is the relation between the dependent variable with respect to each of the independent variable, also between the independent variables. So we identify all the crisscross combinations that we have between the dependent and the independent variables that we have. And we identify what is the correlation between them and how they could be further used for the analysis. So we have adopted a very methodological statistical approach over here to do an analysis for bivariate as well as multivariate analysis. Now we move to a causal analysis where we identify the relation of the dependent variable, which is stockpiling up with respect to each of the independent variable. Then we identify which variable contributes more to the variance of the dependent variable through a correlation scatter plot analysis. And over here, we do carry out a regression, which you can see here, which gives out a regression equation like this, which includes beta 0 plus beta 1 into the X variable that we talk about, sales. Like this, for individual variables, we have carried out analysis over here with the mean, with a different error metrics such as mean error, root mean square error, mean absolute error, mean percentage, and mean absolute percentage error. Such methods have been used here to analyze what is the accuracy or what is the contribution of these variables and how much variance been influenced by the independent variable on the stockpiling app. Now we move to the final part, which is basically in the bivariate analysis, which is sensitivity analysis. Over here, what it says is that the user can change the consumption for the coming periods and see how it would affect the total output. So as you can see here, when I keep changing the consumption, it will give an output which is consistent across the time. And that the user can change according to the time and see how much, if the consumption changes, would affect the stockpiling up. And this would give an intuitive idea as well as an empirical idea about how basically the stockpiling would behave with respect to each of the factors that we talk about. Similarly, we can consider sales and we can see how it is affecting the total output. You would see the trend changing away because we are taking a different level of variable length, variable range that for each of the factors that we talk about. Now we move to the aging analysis. Aging analysis basically it's shown over here, the final output. However, the analysis is a little black box over here because the analysis carried out with respect to the correlation with respect to past period, and we analyze which is contributing most to the current stockpiling up and how it has been influenced over a period of time. However, the final output, as you can see here, which each day how much of contribution has happened, and these are the most discrete effect with respect to the stockpiling up that has happened over the period. And we have identified the key days that contribute to the total stockpiling up. Aging analysis is very important in analyzing from where the source of the stockpiling up initiated and how that could be rectified for the coming future periods, and prior to how many days we need or how many time periods we need to start focusing on affecting how we can see the inventory stockpile up that can be reduced over a period of time. So we can make strategy decisions prior to the stockpiling. Now we move to the multivariate analysis, which is the most important, which in a way is the most important part of the analysis because it provides a multivariate, multiple variables when they come together, how it would affect the dependent variable, which is stockpiling up over here. So it starts with the data, the raw data that we have, different variables that we have considered, as well as exogenous and endogenous variables over here. And then we initially start with causal analysis, which includes multiple methods to identify how, if different variables will fit into the model using a stepwise regression or an OLS method that we have, how it would affect our the dependent variable, and the correlation, the coefficient, beta coefficients that is derived from the regression coefficients that we have is being shown over here. We have multiple methods we have used over here, such as OLS and ordinary least square method and regularization methods such as Ridge, Lasso, and other methods for the analysis. However, for the demo, we have shown only two models over here, only two models such as Ridge and OLS. So these models provide an effective method in analyzing how different variables contribute to the stockpiling up. The regularization methods have been used because in the real world scenario, we do observe a lot of multicollinearity across different independent variables. and this particular output has been shown over here, and the interpreter or the user can understand how exactly each of the variables contribute to the total stockpiling up. Now, and another important part of it is basically variable importance. However, this is slightly different from the approaches that we have discussed so far, because this approach provides an analysis on understanding month to month how different variables contribute to this total stockpiling up. So if you can see here, this is the overall impact which has been happening over the period of time, the total over a particular year and a particular month we talk about. So if I take a particular month, the impact is changing over here. However, this is a total impact over a period of time. That is a total year that we considered, which will not change. However, when I change from one month to another month, the importance of different variables change across here. As you can observe here, in the month of August, we do see price has a lot of importance, as well as machine downtime and consumption. But when you go to October month, we do observe price still has more importance and machine downtime. However, the consumption, the importance has reduced over the period. This is very important in making a decision on strategy decision with respect to a particular time period. The planner for the planning purpose and the machine management purpose, we can plan in advance what factor contributes in. We can focus particularly on that to improve the total stockpile up in that particular period. Now we move to the final part, which is sensitivity analysis. This is an overall. When you have multiple endogenous variables or independent variables that we talk about, we can see how the change in all of these different combinations would contribute to the total stockpiling up. For the analysis and for the demo purpose, we have just shown two variables over here. However, there could be multiple variables, such as more than 20, 30 variables can be included here to analyze how multiple variables come together would impact the total output of stockpiling up. This is one of the most important part of the analysis, because this provides a user to identify how the combination of different independent variables to contribute to the total stockpiling up. And this same method is being further utilized to understand how to minimize the total stockpiling up and what is the optimal combination that would provide the least stockpiling up over a period of time. So with that, we come to the conclusion. We come to the end of the demo with respect to a product. Now, as we already discussed, the methodology and the approach has been explained over here, and what is the final output that we get from here, and what is the business benefits that we derive. With that, we come to an end of this demo, and thank you.